Hello students, today's video is going to be very interesting because in this video you are going to learn a very easy, quick and time-saving trick in trigonometry. With the help of this trick you can write all trigonometric functions, trigonometric identities in very less time and without much efforts. So guys, please watch this video very carefully and please like and subscribe my channel and press the bell icon button. So let's get started. Hexagon is a shape that is made from 6 sides. So this is a hexagon, but I am talking about how we will use this hexagon in trigonometry. So for that we have to remember this thing: tan theta is equal to sin theta upon cos theta, and according to this we have to go in the clockwise direction in our hexagon. These are the different vertices of the hexagon. So we will start from here. We will write here tangent, then tan is equal to sin upon cos, so we will go in clockwise direction. After tan, sine, and then cos, so it will be cos. After writing this much, what we will do, we will use the opposite vertices. So we know that reciprocal of sine is cosecant. This is cos. Reciprocal of cos is secant, so we will write secant here. And this is tan. Reciprocal of tan, we will write in the opposite of tan, so this will be cot. If I will draw a line in between this hexagon, so we can remember that all C's are on the right side of the hexagon. C, cos, cot and cosecant. So you can remember in this way that all C's are on the right side of the hexagon, and you can remember in this way also we are going in the clockwise direction, and opposite trigonometric ratios means sine, reciprocal of sine is cosecant on the opposite vertices, cos, reciprocal of cos is secant, tan, reciprocal of tan is cot. So in this way we can make our super hexagon. Now in this part we are going to learn almost all trigonometric formulas with the help of this hexagon. So first we need to move in the clockwise direction. Clockwise direction we have to move. So when we will move in the clockwise direction, as we know, tan theta is equal to sin theta upon cos theta. So we will start from the tan theta up to cos theta. These three trigonometric ratios we are using. If I will start from the sin theta, then cot theta, sine, cos and cot, these three trigonometric ratios we are using. So as tan theta is equal to sin theta, then sin theta, from sin theta we started, so we will write sin theta is equal to cos theta upon cot theta. Then I will start from cos theta, and three trigonometric functions I will use: cos, cot and cosecant. So cos theta is equal to cot theta upon cosecant theta. And in the same way I will start from cot, and in the clockwise direction, cot, cosecant and secant, these three I will use. So cot theta is equal to cosecant theta upon secant theta. Now I will start from the cosecant theta and I will go up to tan theta. So cosecant theta is equal to secant theta upon tan theta. And then I will start from secant and then go up to sine. So you can write secant theta is equal to tan theta upon sine theta. So in this you have to take care that we are going in the clockwise direction. So clockwise direction. So what will happen if I will move anti-clockwise direction in the same hexagon? If I will move anti-clockwise direction, then let's see. So again I will write tan theta is equal to sine upon cos, then opposite sine up, reciprocal of sine is cosecant, reciprocal of tan is cot, reciprocal of cot is secant, and 1 in the center. All c's are on the right side. So let's see if we will move in the opposite direction. So if I will start from here, cos, then sine and tan. So cos theta is equal to sine theta upon tan theta. Then I will start, if I will start from cot, then up to sine. So cot theta is equal to cos theta upon sine theta. Very easy. Now I will start from cosecant up to cos. So cosecant theta is equal to cot theta upon cos theta. Now if I will start from secant, so secant theta is equal to cosecant theta and upon cot theta. Tan theta is equal to secant theta upon cosecant theta. So in this way you can write down all these relations. Two important things are here: if we will move clockwise and if we will move anti-clockwise. But you have to remember in both cases, clockwise and anti-clockwise, that first thing is equal to second by third. Means first thing, if we are starting from 10, then it is equal to the second function by third function. Second by third. If we will start from sine, then sine will be equal to cos second by, means cos upon cot, second by third. So always remember these things, that first function is equal to second function upon third function. Now you must be thinking that why ma'am has written here 1 in the center. Ma'am is not using 1. Why we are writing 1 in the center of the hexagon every time? So let's use this one. First we will write the trigonometric functions. Tan is equal to sine upon cos, reciprocal of sine cosecant, reciprocal of tan cot, and reciprocal of cos secant. So if we multiply the opposite functions on the vertices, we will get 1. So this is the opposite vertices, sine, opposite of that is cosecant. So if we will multiply these two, sine theta multiply opposite of that vertices cosecant theta, reciprocal of sine cosecant, is equal to 1. Secant, opposite of that, secant theta multiply cos theta is equal to 1. And like this, cot theta, opposite of that tan theta, so cot theta multiply tan theta is equal to 1. Now we will take again the hexagon. We will write 1 in the center and trigonometric functions tan, sine, cos, cot, cosecant and secant. So next trick is, now we will take any three continuous functions in the hexagon, then we will multiply first and third function, and that will give the center one. If we will take this first and third, means I am starting from tangent, this is second and this is third function. So if I will take tan and cos, this is the first, this is the third. If I will multiply these two, then I will get the center one. So how we can write? Tan theta multiply cos theta, first and third. So it will be equal to the center one. This is sine in the center. If I will multiply secant and sine, this is the first function and third function, I will get tan. So you can write secant theta into sine theta is equal to tan theta. Or if you want to start from cosecant, so cosecant theta multiply the third function cos theta is equal to cot theta. So this is very easy, you can remember that. Now focus on the functions at diagonally opposite vertices. Diagonally opposite vertices like sine and cosecant, these are diagonally opposite vertices. Secant and cosecant, tangent and cotangent, these are the reciprocal of each other. So what we can write? We can write sine and cosecant. So sine theta is equal to 1 upon, these are sine theta is equal to 1 upon cosecant theta, reciprocal of that. And like this, secant theta is equal to 1 upon cos theta, and tan theta is equal to 1 upon cot theta. So you can write down in the opposite way also, like cosecant theta is equal to 1 upon sine theta, cos theta is equal to 1 upon secant theta, cot theta is equal to 1 upon tan theta. So you can write down this way also and this way also. So but we need to focus on the functions, those are situated on the opposite vertices, diagonally opposite vertices on the hexagon. Now do you remember complementary angles? So complementary angles means the angles, when we will add these two angles, then we will get sum 90 degree. So those angles will call the complementary angles if we will get sum as a 90 degree on the addition of two angles. So we will use the complementary angles concept in this section. So how we will do, suppose we are starting from the sine theta. So if I will move like this in the next direction, so I can write sine theta is equal to cos 90 degree minus theta. And in the opposite direction, I can write cos theta is equal to sine 90 degree minus theta. So when you will move in this direction, tan theta is equal to cot 90 degree minus theta, or you can write cot theta if you will move in the reverse direction, tan 90 degree minus theta. What else you can write? Secant theta is equal to cosecant 90 degree minus theta. And when you will move reverse direction, cosecant theta is equal to secant 90 degree minus theta. So in this way you can write down the complementary angles that we will use in the solving of trigonometry sums. Now the most interesting part, I like this part in this hexagon, that you see this hexagon very carefully. So we can see that 6 triangles are here. 6 triangles are here, but we will focus on these 3 triangles that I highlighted. These 3 triangles we will focus on that. So first we will move again for clockwise direction. So clockwise I will put a arrow like this in the clockwise direction, like this, like this. This is the clockwise direction. So we will move first in the clockwise direction, and what we will get when we will move in the clockwise direction, this function plus this function is equal to 1. So sine square theta plus cos square theta is equal to 1. This is from this triangle. Now next triangle, the arrow is started from this 1. So first we will take 1 plus cot square theta is equal to cosecant square theta. Next, the third triangle, the arrow is started from 10, so we will write down tan square theta plus 1. 10, 1, secant, these three. So tan square theta plus 1 is equal to secant square theta. So again I will repeat, we will move in the clockwise direction. In the first triangle, sine square theta plus cos square theta is equal to 1. In the second triangle, 1 plus cot square theta is equal to cosecant square theta. In the third triangle, tan square theta plus 1 is equal to secant square theta. This is about the clockwise direction. If we will move anti-clockwise, so if we will move anti-clockwise, what will happen? Let's see. First I will draw the anti-clock arrows in these three triangles. Anti-clockwise. So in the anti-clockwise, when we will move this arrow anti-clockwise direction, so 1 in the first triangle, 1. In the anti-clockwise direction we will use the minus sign. So 1 minus the second function is cos square theta is equal to the third function sine square theta. In the second triangle, first we are starting from the cosecant, so we will write cosecant square theta, then minus cot square theta is equal to 1. In the third triangle, secant square theta minus 1 is equal to tan square theta. So in the first triangle, we are starting from 1 minus cos square theta is equal to sine square theta. In the second triangle, we are starting from the cosecant square theta minus cot square theta is equal to 1. In the third triangle, secant square theta minus 1 is equal to tan square theta. These are the trigonometric identities. With the help of hexagon, we can remember these identities very easily. So after making so much hexagon again and again, we can draw this hexagon in our mind without pen and paper. So it will be easy to remember if you will practice this hexagon trick 1 or 2 times. So that will be a great help in solving the questions of trigonometry. If you like this video, please give a thumbs up. Please hit the like button. And if you have any query regarding this, you can write down in the comment section. Thank you.